Hello, everyone, and welcome to today's SaaS webcast, The Best of Both Worlds, Cloud and SaaS, sponsored by BitGlass. My name is Jessica Gallus of SANS, and I will be moderating today's webcast. Today's featured speakers are Prasid, Director of Product Management at BitGlass, and Ken Hartman, Certified SANS Instructor and Security Consultant. If during the webcast you have any questions for our presenters, please enter them in the Q&A window located on the control panel at any time. Please note that a copy of the slides and recording of this webcast will be made available for viewing later today and can be found on the SANS webcast archives. And with that, I'd like to turn the webcast over to Ken.
Thank you, Jessica. Well, I am one of the certified SANS instructors for SEC 545. That's the Cloud Security Architecture and Operations course. And I'm also a proud alumni of the SANS Technology Institute. I got my master's in information security through that organization. Who here has heard someone say identity is the new perimeter? And who here agrees with that statement? Now, I can argue it both ways, but the reason why I ask is because I want to focus our discussion on first principles. So let's define identity and perimeter so that we can do just that. Now, ISO 24760, which is a framework for identity management, defines identity as a set of attributes about an entity where the identity can either be a person or a thing or system. And the attributes are those characteristics or properties of the entity, things like address, phone number, MAC address, DNS name, and so forth. And the concept of a perimeter comes from military strategy. Essentially, an army would draw a metaphorical line in the sand and not let the adversary cross it, or at least try and defend it to their death. So we as information security professionals, we've adopted this military concept and have applied it to securing our enterprise networks. And as a result, the enterprise network became the security perimeter de facto. However, now our industry has finally recognized that the enterprise network was really never all that secure anyway. And if we're being honest with ourselves, it's best to design our security controls with the assumption that the enterprise network is compromised, or at least will be, and that we cannot trust an entity simply because they have access to our enterprise network. So this thinking has given rise to the phrase zero trust. And then some marketing person started saying, well, identity is the new perimeter. Now the cloud has certainly upset the apple cart. And because now it's easy for an adversary to get access to our network, and plus our trusted users are not always on the enterprise network. And the point that I want to drive home by this concept is that trust boundaries still matter. It's just that the cloud has drastically shifted those trust boundaries, these perimeters, and now there's many more of them. So how can we cope with all of this change? Well, our security technologies must also change along with how we think about the problem. Because necessity is the mother of invention. When there's a specific need, a technology will be developed by some innovator that will address that need. For example, a network hub, well, that connects multiple hosts to a network. And then along came a switch, which separates the hosts on a given network into separate collision domains. Then you have routers to route the traffic between the different networks, and then access points and firewalls and IDS. But innovation continues. And the OEMs developing this equipment, as they started to better understand the market, they tried to increase the utility of these devices and drive down the total cost of ownership. So this naturally started to result in some sort of convergence, where the features of the first generation devices started to become integrated into a single form factor that was tailored for a specific segment of the market. So an example of this would be the blending of IDS and firewall technologies to create what many companies market as a next generation firewall. And the bundling of a switch, a router, access points and firewalls into a small office, home office, broadband router. So with all of these convergences that seem to happen at hyperspeed with internet technologies, it can often be instructive to decompose these converged technologies into their component technologies to get a better understanding of how a given product performs its magic. Gartner excels at identifying and clarifying technology trends. And this diagram comes from the Gartner report called "The Future of Network Security is in the Cloud." On its face, that's a pretty bold statement. Now, our goal is at the end of this webinar, you will be convinced. If you think about it, what is it that gives a business its competitive advantage? Well, it's access to information that its competition does not have. This means that those that should have access should be able to access it whenever and wherever the organization has deemed appropriate to maximize its competitive advantage and achieve the organization's mission. It also means that those that should not have access do not and cannot exploit the value of that protected information to the detriment of the organization. Now, this dictates that we must have an effective mechanism to differentiate who should and should not have access. And this sounds simple in principle, yet access control is the primary focus for security professionals on the blue team. The access control challenge is exacerbated in the cloud because of the sheer number of cloud-based services that are being accessed by the organization's users. So as a simple example, consider a medium-sized company, 5,000 employees. And if the organization uses only 10 services on the internet for work purposes, that would yield potentially 50,000 identities to manage. Then there's also the challenge of blocking access to sites that are explicitly prohibited, and then grappling with how to handle the gray area of the spectrum, like employee banking, their retirement websites, and then there's Facebook, news sites, eBay, Amazon, and the list goes on and on. Now, most companies have policies as to what is acceptable based on the nature of their business. The challenge, though, is how to enforce these policies at scale. And then, of course, once you do decide to grant access, you need to secure that data in transit, but reserve the capability to inspect it. You also need to protect the endpoint from the service, and conversely, to protect the service from the endpoint if that service is containing your sensitive data. So it's no surprise that we're going to argue that the solution is a secure access service edge. But what is a SASE? For that discussion, let's take a look at some of the component technologies. Now, our industry loves its buzzwords. So it's often helpful to ask a salesperson to define the term, just so that everyone's on the same page. Also be sure to ask, well, how does this solve my problem? Each of these technologies solves a specific set of problems, albeit with some overlap. The power of these point solutions is amplified when they are integrated to form a holistic solution with a common management interface and collated logs. Now, there's not anywhere near enough time for me to cover all these technologies, but I highly recommend that you take this slide and do some research as well as the Gartner slide so that you're conversant on each. Instead, I want to focus on just a few of the essential ones. So let's start with the CDN. A content delivery network consists of two main components, the origin server and the edge servers, also called cache servers. The origin server serves up the content, but the edge server is functioning as a proxy between the origin server and the client. So the edge server is typically located in a data center in the general proximity of the client that is making the request and will cache any static content like large images or videos, so that only the dynamic content needs to be pulled from the origin server until the cache content gets stale. And to refresh the stale content, it would just forward the proxy on up to the origin server, and then the more recent content would be cached again at the edge server. So this makes a significant reduction in the overall amount of network traffic because the largest static files are only a few router hops away from the requesting clients, while the origin server may be several hops away. And CDN operators soon realized that they could then add additional value by having the edge servers function as a web application firewall, in addition to caching. And this makes perfect sense since the edge server is already functioning as a proxy with visibility into the traffic. Well, why not have it filter out malicious traffic as well? And now CDN operators are also offering edge computing for certain localized, low latency applications such as IoT. And the power of a CDN becomes even more apparent when you consider its global scale. The dots on this map are where the highest concentration of internet users are. And that's why they have edge locations there. So consider the case of a DDoS attack. In this case, the attacking hosts are distributed by definition. So a DDoS attack on a victim website would be directed at the nearest edge server, which effectively dilutes the attack, shielding the origin servers. Okay, now let's take a look at cloud access security brokers. Simply put, a CASB controls access to an organization's information that is in the internet by controlling access from both managed and unmanaged devices, whether they're on a corporate network or not. And a CASB does this by proxying or brokering the traffic to the cloud services. Now, how the brokering works will vary based on whether it's a managed device or not. But I like to say that a CASB is an authorized man in the middle, and as such, it can apply policy to permit or block traffic based on the identity of the user and the identity of their device as appropriate for the internet service that's being accessed, as decided by the organization. Now, unlike a CDN or a WAF, which are reverse proxies only, a CASB functions as a forward proxy with managed devices. So are you starting to see the power when these technologies converge? And then next is secure web gateways. Traditionally, a secure web gateway would be installed in your data center to proxy egress traffic, a forward proxy. So I should state what a forward versus a reverse proxy is. Forward proxies are in front of clients, whereas reverse proxies are in front of servers. So a secure web gateway is essentially a forward proxy, and this works well when it was located in the data center until you start having more and more remote users and bring your own devices. Then you either have to route all traffic from the remote users back to your data center, which is a terrible idea, or base your secure web gateway in the cloud, at which point your secure web gateway starts to look more like a CASB. So in hindsight, it seems logical that you'd see this type of convergence by the innovative companies, such as BitGlass. Now also note there's a core function, and that's endpoint inspection, which is kind of a segue to my last buzzword bingo square, which is endpoint detection and response, EDR. And although the Gartner report doesn't specifically call out EDR as one of the converging technologies, we do know that CASBs and secure web gateways work best with an agent installed on the endpoint. And I'll explain why in just a moment. But first, consider that most enterprises do not want to have multiple different agents on their endpoints, especially when some of that functionality overlaps. Okay, so here's why. Google is one of those companies that's very involved with the Internet Engineering Task Force. And they've worked, collaboratively with multiple organizations to make improvements to TLS and HTTPS, and even introduce certificate transparency, all in an effort to make man-in-the-middle attacks difficult, if not completely impossible. So this makes it a challenge even for a legitimate proxy. So what is the workaround? Well, use an agent on the endpoint that can tap into the TCP/IP protocol stack. And this brings the proxy right down to the endpoint for a completely integrated solution. And since you need to verify the security posture of the endpoint anyway, it would just make sense that that same agent would be able to do that and be managed from the cloud. So with that, I'll turn it over to Prasid to cover the BitGlass solution.
Great. Thanks, Kenneth. Let me try to share my screen. Can you guys see my screen? I hope you can see my screen.
Yes, it's working.
Super. Thank you, Kenneth and Jessica, for that brief introduction. Let me jump right in. I have a few slides that I will first go for. I'm going to talk about this is the agenda for the next few minutes. I'm going to talk about the problem space that BidLass as a company is trying to go and address. And with that, I'll just set the stage of how enterprises are currently divided. And then I'll jump into a solution that we have come up with, how our product is evolved and trying to address those problems. And I'll introduce this construct once again, the secure access service edge, and how that plays into the unification of all these buzzword bingos that Kenneth mentioned. I'll tell you a brief about how legacy cloud security has been architected, and then jump right into BidLass's own SASE solution. So it'll be twofold. One is our CASB plus Secure Web Gateway product offering, and then I'll also touch upon the SASE fabric, which is how it's architected overall. And I'll give you an example of organizations that are powered using the BidLass SASE fabric. And then I'll do a brief demo of our SWG and CASB capabilities. Finally, I have a section for FAQ and resources that you guys can leverage in order to extend beyond this webinar. I'll jump right in. So the problem is a typical enterprise has all these varying components. The first thing that they would have is a bunch of devices that they give to their employees, which is what is referenced here as managed devices. The next thing that they have to handle is unmanaged, which is my personal PC that I come in with and I try to access my corporate sanctioned resources with. Having said that, what does a user typically access? It's all these applications that are available in the web. It could be a Slack, Zoom, WebEx, Office 365, G Suite, any of these managed applications. That's the first section of applications. The second one is internal apps that are hosted on your premises or something that's custom for your particular enterprise. That's the second set of categories that people typically tend to access. And then the third thing is web and unmanaged apps. These are personal apps like LinkedIn, Yahoo, WeTransfer, any of these apps that people generally try to browse. Now, all these are places where your crown jewels of your enterprise could reside in. So the data that you have needs to be secured when people are trying to access from these varying devices into these applications. That's the ground truth of the varying component. Problem is typically things have been done through firewalls or single points of enforcement, but as these global architecture is required, then the traditional way things have been architected no longer suffices. So that's when that's the problem statement in general that we are trying to address and move towards. So let's jump right into the solution. Just to give you a perspective of the moving pieces, I'll have about 7 of these different pain points that we go and address. First one is so these include also deployment modes that a CASB or any security offering that you require should adhere to. So the first thing is API-based scanning. So this one we traditionally refer to as out-of-band scanning, in the sense that it's after the math of some kind of event. So let's say you upload a file into underlying SaaS application, let's say Office 365. Once the data goes there, we have API controls that particular SaaS application exposes. So let's say Office 365 has these APIs that security vendors can then tie into in order to perform these capabilities like DLP, which is data leakage prevention, malware analysis, which basically protects for threats on the upload and download direction, and the ability to share and sharing control. So in the sense that if you have a file that resides in the cloud and it's publicly shared, you might not want that. So the ability to whitelist, quarantine sensitive files, and the ability to control your sharing capabilities as well. So those are capabilities that pertain particular with API-based enforcements. The second thing that I want to address is forward proxy. As Kenneth mentioned in the initial intro, forward proxies are agents that are deployed on these endpoint devices, and they provide real-time access control, DLP, and threat protection. So that's another way in which you as an enterprise can look for securing your managed devices. Now, the third thing that I want to touch upon with emphasis is our smarted SWG. I'll go a little deeper down the line, but just a quick high level is that the ability to do URL filtering. So URL filtering in the sense that at a global level, you can enforce access controls and block or allow certain category of applications. So as an example, it could be a productivity suite, malware applications, gambling sites, different set of categories based on which you can enforce policies on. So now, in addition to just filtering, you can also do threat protection, which is basically protecting against upload or download of malware. And the other one is DLP, which is fine-grained access, fine-grained control of patterns, which are contained in a particular file or blob that's sent up or down into a web application. So the key thing to note is with the evolution of secure web gateway technology, one thing as an enterprise that you want to emphasize or focus more on is the latency and the user privacy. I'll go a little deeper into that segment in my upcoming slides. The fourth thing is reverse proxy on any device. So this one jumps right into unmanaged devices particularly. So let's take a healthcare organization like a hospital. They would have doctors typically tend to be affiliates. They are affiliated to multiple hospitals. So in those use cases, reverse proxy comes very handy, not just in those any BYOD scenarios. If your enterprise is BYOD, then the reverse proxy is a compelling solution to have in your arsenal to protect your crown jewels. And the way BitGlass does it is unique. So we have our agentless real-time proxy. So it provides visibility DLP for your managed applications in general. So that's the unique selling point of BitGlass, where more than 98% of our customers leverage this capability from BitGlass in order to go and reverse proxy their applications. So as our host initially mentioned, reverse proxy ties into the server side of the application. So the reverse proxy stays closer to the application in general, not at the endpoint. So the way BitGlass ties into your reverse proxy is through the single sign-on offering right at the time you log in. So the fifth thing that BitGlass uniquely differentiates itself from other vendors is that we have our own inbuilt identity as a service offering. So this is integrated with our reverse proxy as well. So everything works seamlessly with native identity and MFA controls. So in addition to that, we also integrate with other third-party IDPs like Ping, Okta, any of those guys as well. So the sixth thing, which is visibility. So this could be in a variety of forms. So visibility, all visibility means is like your inspector comes into your home inspection, he gives you a thorough analysis of everything, and then he writes a report and gives it to you. So think of it the same way. The shadow IT, the typical analogy is a shadow IT report. So where you can upload your firewall logs or anything, and we provide you with reports which give you rich information about all the applications that you access. Now, in addition to just visibility, we also are able to provide misconfiguration management. That's what's covered under this construct called CSPM. So it stands for Cloud Security Posture Management. It's exactly like your inspection reports on houses, where we find out all the loopholes that are there in your underlying infrastructure as a service, and we try to provide you with recommendations on how to remedy this, right? So the remedy could be manual, automated. So however you wish to enforce those remedies in your enterprise. And the way we do it is using the standard benchmarks that are available that we compare against and provide you best practice recommendations. So the final thing that is of utmost importance in today's world is zero trust remote access, where you want to enable your workforce, remote workforce, in order to access these applications. And the way BitGlass does it is pretty unique in the sense that we require no agents. So our reverse proxy ties into these applications that are hosted either on-prem or cloud applications. So in general, in order to provide native controls such as access, identity access management, DLP, and threat protection. So that's a quick high level around different solutions that make together to form this cohesive platform for you guys offered by BitGlass. So with that, I'll introduce you to the construct that Gartner's coined, since I think it's been last June or July when they came up with this, where they said you want a cloud delivered solution to provide a connected experience for customers across different product lines. So we as BitGlass started off with this cloud security piece, for data protection, threat protection, identity visibility, which is captured by the CASB side. And then as the product line evolved, we ventured into the SWG and adjacent capabilities, which offer a collective solution. So there's cloud security and there's network security, and the convergence works great. Now, where is this SD-WAN capability? And BitGlass as a company leverages AWS as an offering. So as for our infrastructure as a service. So all our services are delivered from AWS. Now we leverage AWS's native backbone and their constructs for CDN for their edge data centers. So this is powered by their thing called as global accelerators, which are edge data centers. I think Kenneth mentioned in his slide deck, he had a list of locations, over 200 points of presence where AWS is hosted on. So we leverage that backbone in order to deliver light speed solutions for you guys. So where we we trust on AWS for delivering that service. And then we as a security company focus on providing you with best-in-class security offerings and points of controls and enforcement. So that's the twofold. And with respect to network security, BitGlass currently provides a URL filtering capability followed by remote access and threat prevention, which we partner with CrowdStrike, Cylance, and Bitdefender on. And then we also have our DNS capabilities as well. So I'll jump right into how legacy vendors are architected and how legacy security has been delivered and why we should look at it from a different perspective that BitGlass offers, right? So typical enterprises would have some kind of these endpoints in their the differentiation would be headquarters versus branch or offices versus remote workers, right? So every time somebody tries to access, they go through one of these points of control. So either these large box appliances, which are heavyweight duties that run in your HQ, or these branch offices, which are running to these lower points of presence. One is called, let's say, super point of presence, and the other one is like a branch office appliance. So these appliance-based backhaul kind of approaches induce all these outlined challenges, which is high management overhead, latency, again, the number of hops before you reach your destination. Every time these appliances are racked and stacked, then when it becomes moot, you have to rely on your security vendor to actually do the patch management and all that. It adds additional sets of overheads. Now, with these cloud service providers providing this capability out of the box, it's in the best interest of the security vendor to use those as the backbone and not rely on ourselves, take the challenge onto ourselves for racking and stacking all these obsolete equipment. And the same way, performance, uptime, and improvement in cost is all uncovered as you go towards that model. So that's the premise around legacy cloud security and how traditionally things have been done. And let's look at what Gartner's thoughts are around that kind of a model, right? So what they say is that anybody with an enterprise data center at the center of connectivity is an inhibitor. So with the changes in business requirements and the way people are looking to consume these services, that's something that people have to keep in mind, that data center being a bottleneck is not something that you should go towards as you plan your next set of security vendors. And the shift in paradigm where we as security vendors are delivering policy-based services, that's pretty much what your security vendor should be heads down focused on. So that's their recommendation as well. So now let's look right into how BitGlass differentiates ourselves. So these points of presence that is outlined here are points of presence that are available on AWS in our underlying backbone. And then these, the way we deliver SASE is secure SASE. So SASE stands for Secure Access Service Edge, but we truly take it to your edge where we have secure access service at your edge, right? So what I mean by that is you have these endpoints or your laptops in general, and in those laptops we install our smart edge endpoint agent, and what it does is it packs all those offerings that we have in the cloud into that particular endpoint. So now, why is this something that's unique? The reason being, traditionally laptops were not the most powerful devices that are going around. But today's laptops seem to be carrying much more rigor, much more strength. So when we come up with the solution our laptops are able to handle that resource and kind of deliver the same set of value that your cloud or backhaul kind of approaches would do. So the way we'll go into the architecture of this, but at a quick high level, so the smart edge proxy that we have resides on every endpoint. Any other endpoint, any other devices apart from your laptop, like your printers and scanners, those that do not have agents on them, they can still use our cloud proxy in order to protect any sensitive data that could go out. And then unmanaged devices traditionally can always go through our reverse proxy solution in order to access those crown jewels. So if you as an enterprise can go into or sanction your user, let's say a doctor, to actually use, let's say Office 365 or Box through our reverse proxy. So that's the premise, where you have all these guys using either the agent or a tunneling mechanism in order to access resources on the cloud, or coming from unmanaged devices and endpoints in order through our reverse proxy. So the unique solution that the reason why we are able to deliver the solution on the endpoint is through our patent pending trapdoor proxy technology. So the way we like to call it as your own head does not trust your tail, right? So in the sense that anybody, traditionally how things have been progressing or things have been delivered is that you have a central CA which actually controls, manages the certificates. Now we push that with our smart edge proxy, where the proxy generates a CA cert, and which is used to inspect all these, used to sign the server certs, for example, CNN, NY Times, any of those, and then use it for TLS inspection. So now the ability to push TLS inspection up to your endpoint is truly game changing, in the sense that users' privacy is preserved, and then the latency for doing this through multiple hops is also preserved. So now let's take a hacker, and the main reason for doing this is to protect against, let's say, man in the middle and other things. So let's say a hacker, he comes inside, he steals one of your certs from the endpoint device, and he runs away with it, and he's trying to use that certificate in order to access resources from a different endpoint device. Now, with our unique solution, which is our smart edge agent proxy and the trapdoor proxy, the head does not trust its tail, in the sense that the proxy keys or certificate are unique to the device. So it's immune, so the hacker can no longer trust this. So the device would obviously not work, and he would not be able to access your crown jewels. So this uniquely differentiates us, and the same way he cannot access the certificate in order to go through this connection as well. So everything's blocked all around in order to protect any kind of man in the middle attacks. So that's the unique differentiator with our smart edge patent pending proxy. So that's how we deliver this capability on the endpoint, right at the endpoint to your device. So two key things to keep in mind is improved user privacy and then improved latency. All right, so let's quickly compare between the offerings that legacy vendors do and how BidGlass differentiates itself, right? So I'll just touch upon the BidGlass ones, where we truly leverage AWS's backbone in order to leverage their elastic cloud. So there are no appliances. We do not go and stack and rack and stack all these appliances and keep patch management going and all those kinds of things. So what that also means is we are able to continually increase our or scale up whenever there is surge in loads and so on. So for example, if you are a company who has multiple surges, for example, you have multiple sales kickoffs or stuff like that, our systems are automatically able to scale. And we call this technology as Polyscale, where our systems are designed to polymorphically scale wherever we see surge of loads. So when it reaches a certain point, we clone our systems. And the reason we are able to do this at cloud scale is because we do not have any machines that run stateful applications. So everything that we have, all the systems that we run, services that we offer are stateless. So the way we are able to deliver, for example, API scanning and stuff like that, it's all stateless. So each machine can self-replicate itself and produce the same functionality that other machines were delivering. So all those capabilities are unique to BidGlass. And then our intelligent endpoint agents handle bulk of the traffic, which means we push this powerful endpoint agent to your device, and then the corresponding policy enforcement happens right at the edge and not backhauled into central enforcement point. So again, as I mentioned, the low latency and user privacy are key things that BitGlass is able to deliver on. Now, the two things that we have developed recently is, one is the agent, the smart endpoint agent, and then the cloud proxy, which is like a IPsec or VPN tunnel, which would basically help you to perform the same levels of controls and route your traffic into the cloud proxy. So the ability with CASB capabilities, URL filtering and threat protection, all that is delivered both at the endpoint and on the smart edge agent proxy. So quick time check here. We have a few more minutes. I want to show a demo for you guys as well. So right now, let's take a quick look at the fabric, SASE fabric, right? So we have global core data centers. These are our super, let's call it super points of presence, which actually are located in multiple regions across high availability zones on AWS. Now these in turn are connected to local edge data centers. So let's say you are in APAC or Latin America, and we have used AWS's global accelerators in order to quickly route any user traffic to the local to the local edge data center, which means that if you are, let's say, browsing from any region in South America, Chile or Brazil or any of these regions, we would quickly route you to the corresponding local edge data center. And then with that would basically identify the quickest path towards our global core. So that's a unique capability that AWS offers, and we are able to make our smart decisions and enforcements based on that. And this technology is powered by any cast IPs that AWS has, so you guys can go and look up for those things. In addition to that, we also have CDN caches deployed globally for less dynamic content, which is also something that quickly retrieves and improves the speed of response for our services. The final thing is the smart edge endpoint agent, which resides on all these managed devices, which actually can perform the same capabilities right at the edge. So a couple of quick customer references before we jump right into the demo. So one, this is a classic customer who's a global financial services customer. They've been using BitGlass in order to secure SaaS applications, popular SaaS applications. So in their case, the challenges that they came up with was securing productivity for any device and any location. The location in the sense that, let's say a user is coming from Singapore, he has a different restrictions versus a user coming in Switzerland, so on and so forth. So all these ability to apply location-based policies, device-based policies, identify your device profile and enforce those were very critical to them. So in addition to that, they also wanted DLP, and BitGlass has our own DLP library, which we manage and maintain. And the unique thing about that is it allows regex, all the traditional DLP solution support. We deliver that and we provide that as prepackaged in our security offering. So it was very crucial for them to overcome their challenges. And they also liked our Ajax VM capability, which is a reverse proxy solution. And the reason it is able to provide the reverse proxy, which is proxying the traffic that goes through and enforcing right from the time user logs into an application till the time he logs out of that application. So the ability to enforce controls, that's something that was unique to BitGlass. And the key thing I would like to highlight is all these things, all these services that or security offerings that you try to roll out typically take a long time to roll it out for your users. And this particular customer experienced our lightning speed white glove solution, where we rolled out in light time in 3 weeks. So those kinds of offerings where you can get started without boiling the ocean and talking about all the solutions. You're just getting started and kind of identifying your key pain points and then going and deploying the solution makes it happen for you to onboard applications, new applications which are cloud delivered, and continue to secure them in a scalable manner. So apart from that, the BitGlass advantage, as I told you earlier, the Polyscale architecture cuts the case for scaled security offering. and the ability that we are a low touch point solution, in the sense that you come in, you plug your policies, and then you run away, right? So those kinds of low touch point solutions are some things to keep in mind, where you established a list of controls that you want to do, and then you just have these weekly reports and notifications come to you as and when there is any abnormal behavior. So that's a key ability to secure SaaS applications that we offer. So next thing, which is obviously more interesting for the current trend, is zero trust productivity. So in this case, we have a 100,000 user organization, a global 2,000 manufacturing enterprise whose headquarters is in Japan. So what they wanted was the ability to overcome or get rid of their VPN to the corporate network, which caused bottlenecks for remote workers. So when you're trying to access it from remote, access your resources from remote, so you don't want to backhaul all the traffic, go to your HQ and then route from there, right? So it causes a lack of seamless experience, right? So with that said, the ability to do the security controls like DLP, threat protection, right where they need it, that cut it for them. So the ability to enforce real-time inline controls with and without agents, that's the bid class advantage that they saw the light of. Okay, so let's go straight to a demo. So I have so first I want to show you a quick high level around how bid class policies are enforced. We have these admin portal policies that people can enforce. So these are based on groups, access method, device location. And you have a bunch of login policies. These are enforced right at your login time, where your basically behavior is either, let's say, consecutive login failure or anomalous behavior, inactivity time modes, and so on. And then these are our new capabilities with our web browsing policies, where we are actually enforcing policies based on categories, URL categories in general. So over here, you have a bunch of URL categories. We make use of webroot in order to deliver these solutions. So obviously, in addition to webroot, you also want to create your custom categories. So the ability to create custom categories is another thing. And then we also have a shadow IT database, which is categorized under enterprise app categories. So there are a bunch of ways in which you can enforce policies with high fidelity. So if, for example, you find out that, let's say, malware or something is too high level in these categories, you can then go into the bid class enterprise categories and enforce it at a much granular level. So that's the policy enforcement point from the URL categorization perspective. Apart from that, we also have the ability to go and enforce policies based on reputation scores. So if I say that I want to categorize everything that belongs to financial services, healthcare, and medicine category, and out of those, I don't want to block everything, but I want to block only the risky applications, right? Then you can enforce policies like this. We also have an enterprise score, where it's a score based on our shadow IT capabilities, where we score applications and URLs from our 600,000 odd application database. And each application has its own list of categories, list of scores, and you can enforce policies based on that as well. And from an action perspective, you can enforce direct app access, which is like, hey, I don't want any inspection on this, you just go direct. Or you can say, hey, I don't want anything to do with the particular customer exception and deny access to this particular application. Or you can say that provide a useful DLP policy when somebody tries to go to those applications. So now these are high-level high-level URL category-based policies. In addition to that, you can also have managed applications. These are very specific applications that your offices has purchased licenses for. So a classic example of that would be like Office 365, Box, Dropbox, Slack, and any of these guys. So in this case, for the demo purpose, I'm just going to show you Slack, where let's see, where is Slack configured? Okay, so we have Slack here, and I've input a bunch of policies. So I'm going to use the secret caps one, where I'm going to show you that when I'm downloading this content, the action is supposed to be blocked. And here I'm going to show you a PCI credit card, where the action is masking data. So with that said, you can also enforce inline notifications. These are slick messages that pop up for your end users when they try to access sensitive content, either upload, download, any of those sensitive actions, right? That said, let me show you a quick demo. So I'm logging into the application. Once I log into this application, it tells me the smart edge agent beautifully comes up and it says that, hey, so-and-so user has been logged in. So once I log in, I'm going to try to go to Slack. So as you know, as I told you, I'm going to have categories like Poker Stars, for example, is a gambling application, as I showed you. So where is that? I think I had a gambling policy. So yeah, web browsing, it includes gambling and adult-related content and so on. So quickly it blocks the application. So now let's say I go to this application called WeTransfer. So I say, hey, let's go to WeTransfer. And when I'm trying to go to WeTransfer, it immediately says coach. So this is like your classic. Even Stephen Curry, who is playing basketball, requires Steve Kerr in order to tell him that, hey, you cannot always shoot 3-pointers from the half line, right? So the same way, there is a possibility to coach your users in order to go to the box, right? So in this particular case, we have this. Where is this application? So we have WeTransfer, and the policy that we have enforced is coach. You can have custom messages in order to route them to the respective application. So now let's see malware. So let's say I go to some malware website. I'm saying that, hey, let's go to the malware domains list. So let's find out what malware website I can go to and try to access something sensitive, right? So I go into this website and immediately it says block. So why did it block it, right? So we have our policy again enforced for protecting against malware websites, right? So anything to do with malware sites, block it. So what else did I want to talk about? So let's go to the workspaces. That's much more interesting. So in this case, I have Slack Enterprise Grid. So Slack Enterprise Grid is offering, or a Slack plan, which has ability to have multiple workspaces. So in this case, I'm going into this one. The workspace is Acme Annuals, and let's say first I want to upload some sensitive content, right? So I'm gonna input a PCI stuff. So immediately it says, hey, you know what? The particular policy matched on PCI credit card data, and the action is altered to mask portions of the content. Isn't that slick? So that's pretty cool in the sense that you as a user are not able to upload any sensitive content into a managed application such as Slack. So let's see what that policy was, right? So in this case, I was uploading something. So in the case that PCI credit card, and the action for Slack message was mask data. So it worked beautifully. So let's now see if we can upload this particular content. So I have the PCI data here. I'm trying to upload it. Immediately says, hey, you're blocked. So okay, I say, okay, let's remove this. I upload. So I try to load messages, nothing. So there's no file that was uploaded. So let's see if we can do the same thing along the download direction as well. So I'm uploading a secret cats project. So I say, hey, just go through. So see what happened there. So right now, when this particular application went through and you're trying to download this particular application, it's going to block you. So when this application is downloaded, you get a block message. That's the idea for upload and download block. So in this case, the upload was blocked. Let's see. So the policy for this one was when you try to download this particular content, the download should be blocked. Let me check this quickly. Second. Try to upload this file once again. All I'm trying to do is basically upload this file, and then the ability, when you download or pull this file from the cloud, it should block contents. So while that loads up, I'm going to show you one more example of a read-only message, which is much more interesting. So let's say you go into LinkedIn and you're trying to access your own personal LinkedIn, and immediately what we do is ability to render the application as read-only. So in the sense that you can no longer post content into LinkedIn, but at the same time you can continue to use the application. So in this case, my traffic is being proxied by our application, and I'm going to try to try to send a message to one of my coworker. Obviously, this application is rendered read-only. Let's see, hello. Try to send it to a coworker. Okay, see. So it immediately says, hey, your particular content was blocked, right? So the ability to coach applications, the ability to render applications read-only, enforce upload and download DLP policies is all something that we can do. That's a quick demo. Finally, I will give you a brief around the cloud security return on investment. So with our unique approach, we can cut costs on appliances and software. So in the sense that if you as an enterprise are looking for your security vendor, you can actually look for offerings that we do focused around security, and we deliver this with our cloud service providers in AWS or with AWS, and improve productivity on any device and anywhere, and followed by scalability and performance, the light speed, latency that we can provide, and strengthen your security and reduce risk and rapid deployment, which was 3 weeks in a case I showed you. We can make that the same for your offerings as well. So with that, a couple of FAQs I had ahead of time, but I'll take any other questions that you guys have, but these are pretty self-explanatory. I'll leave it for you. With that, thank you. Over to Jessica if we have any other questions from the audience.
Okay, great. Thank you. As we wait for some more questions to come in from the audience, first question that we have is, could you explain the difference between approved and sanctioned?
That's a great question. So they go hand in hand in the sense that we interchangeably use approved or so approved is, let's say your IT team within the organization is approving usage of that application within your enterprise. That's approved. Sanctioned again is similar. So those are synonyms to be said. Approved and sanctioned go hand in hand. And there is also licensed, which is another word which keeps coming up interchangeably. So all those refer to the same. And the opposite of this is unlicensed, unsanctioned, or unapproved. So those would be just whether it's approved for usage versus not.
Okay, great. Thank you. Next question is the endpoint agent lightweight?
Yeah, the endpoint agent is lightweight in the sense that it has very limited resources that you can consume, resources that it consumes, and the ability to do inspection is also based on a lightweight cache that we have, which actually keeps refreshing every 5 minutes. And then it's also a push model where we push enforcement, or it's via a pack file that's managed. Again, the ability to update policies happens every 5 minutes. And we also make sure that it doesn't have a heavy overweight. So yes, the answer is it's a pretty lightweight endpoint. Endpoint agent. I mean.
Okay, great. Thank you. That's all the questions that we do have at the moment. Do you have any closing statements, you or Ken?
For me, I think this was a very high-level presentation, tingling you to come and look at our solution in a much more detail. Happy to discuss with your respective organizations if you have security challenges that need to be addressed.
And nothing from me. It was a pleasure to co-present with Prasid. Thank you, everyone.
All right, thank you. Well, that's all the time that we do have for today. Thank you to our speakers, Prasid and Ken, for that great presentation, and to BitGlass for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.